Okay, the fun part of the morning is over now. Now you have to listen to boring lecture that all the movies argued against. The worst kind, the PowerPoint lecture. So I want to talk about CSCL, which is Computer Support for Collaborative Learning, in two cases. One is the teaching that I do at the high school, and the other is a research project that I'm involved in at the Math Forum. So there's 4 parts to the talk. The first part, I want to quickly give a little theory of information, how information has sped up in a more quantitative way than the movies showed, and contrast with that with the slowness in which educational technology has fallen behind those changes. And then give these 2 examples, the Virtual Math Team's research project at the Math Forum as a prototype for using technology to support collaborative learning online, and then talking about how we're trying to develop technological use in the classrooms here at the high school. So the first section of my talk is on these changes in information and how quickly it disseminates around the world. And so I want to distinguish, mainly we have these traditional distinction between the oral epic and the literate epic, when people started writing and civilization began, and the huge transition in consciousness that took place and in society that took place here. And some people argue that the computer revolution is going to produce similar kinds of social changes. And I want to distinguish the network era from just the computer era and look at the opportunities that brings. So I've made this little chart, which I won't go through completely, but just to emphasize the network era, when we now have technology with all the interconnected computers on the web, on the internet. And mainly, I want to emphasize that this allows us now to share everything globally. And in theoretical terms, what this creates an opportunity for is what I call group cognition, where the agency of developing ideas and developing information is based in small groups rather than in individual minds and individual people. And the form of education that goes with it is no longer the classical tradition and transfer of knowledge through, like I'm trying to do now, through lectures, but rather collaborative knowledge building. And there's different kinds of educational technology that support these different forms of education and so on. And I want to argue that CSCL is a form of technological support that's tuned to supporting collaborative knowledge building and group cognition. So these are 2 quotes from my book. This is the first sentence in my book on group cognition. The promise of globally networked computers to usher in a new age of universal learning and sharing of human knowledge remains a distant dream. The software and social practices needed have yet to be conceived, designed, and adopted. So what I'm arguing in the book and in my talk today is that while the hardware is there for the technological transformation of society and learning and information, the things that use that technology, the software that runs on the hardware, and the social practices, like how one teaches in the classroom, how one learns in the classroom or outside of the classroom, these have not yet been developed very extensively. And so the promise has not yet been fulfilled by any means. And like I mentioned, I focus on small groups as the engines of knowledge building rather than on the individual, which is the traditional focus for creating new knowledge. And I argue in my book that the knowing that groups build up in manifold forms is what becomes internalized by their members as individual learning and externalized in their communities as certifiable knowledge. So small groups form a middle ground between the individuals and the individual learning and larger communities like large classrooms and schools and various communities of practice. And so the knowledge that gets created in small groups gets picked up at the two other extremes by individuals as they internalize that knowledge and by communities as they make use of and adopt that knowledge. So this was the chart that you saw before. What it is it's a chart of how long it takes information to propagate around the world and how that's changed in history in the last 3.5 billion years. So 3.5 billion years ago, it took a long time, like 100,000 years, for information to propagate around the world. Now it takes seconds. And the change over this extremely long period of time has been almost a straight line when you plot it on a log-log chart. A log-log chart means that it's exponential growth in this dimension and exponential in this. So the straight line indicates doubly exponential growth, which is almost unheard of growth that's speeding up. And that's why we see the kind of things that are even noticed on YouTube, that information is coming faster and faster. And we're not really equipped to deal with it because our biological evolution in the last few billion years has been adaptive to much slower transformations of information. And so now we need to develop, because our biological evolution can't keep up with it, we have to develop cultural evolution and technological evolution to deal with these changes. So I wrote this article a few years ago, The Rapid Evolution of Knowledge. You can look it up there. And all I want to do in this talk is to contrast how fast knowledge is changing with how slow the educational technology is changing, how difficult it is to change the way we teach and the way we use technology, and to develop and design and develop the kind of software that's necessary to take advantage of the hardware that we already have. And that's what my book is mainly on. So now I want to switch from that first section that talks about how information spread and dissemination is doubly exponential in its growth, to how slow educational technology is changing and why it's, what are some of the issues that make it so slow. So there have been, even in the last couple decades, there have been several stages of change in educational technology. And these are some of the general terms. Computer-aided instruction, which is the kind of drill that you see in these math things that just give you math problems and say good boy or good girl if you get the answer right. Intelligent tutoring agents based on artificial intelligence. Programming environments like Logo. And then I think kind of a step backwards is these instructional management systems like Blackboard, which really bring along very little educational content. They're mainly management tools for universities. And then CSCL, which is the current technique that I've been researching. So some of the older technologies, even though they use these new computers and networks and so on, they're still based on this pedagogical theory of transfer of factual information, the same way that lectures are based on that. And they still focus on the individual as a lone learner, even something as progressive as Logo, in terms of being a constructivist and part of progressive founded on theories of progressive education. It's still focused on the individual rather than the small group. And they assume, for classroom, they assume that the teacher is the center of the universe and everything has to go, all learning has to go through the teacher. But collaborative learning, in contrast to that, is functioned on not transfer of factual information, but the creation of new knowledge by not individuals but small groups, and not teacher-centered but peer-centered in collaborative work groups, and based very much on discourse. So the emphasis is on how kids in small groups learn to speak new languages, like the language of mathematics or language of information theory. So again, the point is that we need to design new software to support processes like collaborative learning online. The hardware is basically there in most places in the world, but we don't really have appropriate software to take advantage of that. And we need to support social networking of people, which turns out to be a very hard problem, of how to get people together, how to support them, how to give them feedback, and so on, with automated systems. And so for HCI, which is something that's taught at the high school, Human-Computer Interaction, it raises a number of kind of new issues that didn't used to confront HCI. And so there aren't really, within HCI, there aren't really answers and techniques for designing software to meet these problems. How do you support interaction within groups? Most HCI has been focused on desktop applications for individuals. And they mostly assume a kind of universal user rather than supporting a whole variety of learners with different kinds of learning styles and needs. You also have to support specific knowledge domains, like for the Math Forum software, we have to support mathematics and what that means, mathematical notation, mathematical simulations, and so on. And then there's issues like privacy and a business model for getting these things adopted and used. So I want to show you the results of our research project that's been going on here for about 5 or 6 years, called the Virtual Math Teams Project, or VMT, where we've tried to design software to meet some of these needs. And I want to emphasize, as soon as the music calms down, how we support 3 levels, 3 distinct levels. So keep this in mind. 1 is the individual learner, 2 is the small group, and 3 is the community. And the slides will be numbered 1, 2, and 3. We use mathematical notation here. And also integrate learning on all 3 levels with the technology. So on the individual level, if we think back to sort of the classical view of education, of college education, the young student, usually male, of course, goes off to some elite university and is confronted with all the wisdom of the world. And one way that's done is because the elite universities have elite libraries. And another is that the future leaders of the world are there also, so the student gets to meet and socialize with those people. And there are also experts in the world's knowledge who guide and study and apprentice the student. So that's the classical view of education. Now that we have a mass society, it's harder to do that. And the question is, how can we support the needs that were met in these ways by the elite schools? How can we support that now in a school like Drexel that was established to serve working class students and so on, who aren't necessarily part of the elite? Well, I'll assume that we've already solved the library problem. We have things like the Internet Public Library. So anybody can go online and get access to the wealth of information. And so the question then is, how do we support peer socializing and networking? How do we support access to expertise and apprenticeship? with online, in an online context. So this is the what we call the lobby for VMT. And we have a number of different, and we've just really started prototyping and developing different social networking functionality for to support individual needs here. And here we give the individual students who come online come into the lobby access to different chat rooms on different topics of mathematics, like patterns and sequences in mathematics, so that they can find a chat room with people who share their interest. So again, we're trying to support this new opportunity that allows learners to network with other learners around the world, and thereby to overcome their isolation. A lot of online learning is very alienating if it's focused on individuals, because it isolates the individual learner. And we want to overcome that isolation by putting them in groups of peers where they can interact and socialize online, just like they used to do in the dorms of their elite universities, and to overcome the alienation of solitary study, but also to leverage the enormous advantages of collaborative learning. And I just listed some of them. That really collaborative learning is the foundation of social learning. All learning begins with collaborative learning. If you think of an infant starts to learn with their parents and their immediate family, and then kids learn with their peer groups, and in classrooms where there's collaborative interactions going on. Then if we move to the level, see number 2, now we've moved to the level of supporting small groups and learning in small groups. And within the small groups, the individuals still have an important, essential role, and they still learn as individuals by participating in the groups. And then the group knowledge is also disseminated to larger communities. So I argue that the small groups are a way of supporting the socialization and the apprenticeship that are missing in other online approaches to education, but that were key areas in the elite model of learning in the elite universities. And the way they're supported is because we get students to talk or chat with other students, and that's a form of socialization, which is really a quite effective form. And they also they apprentice something like, in the virtual math teams, they apprentice themselves as budding mathematicians by engaging in mathematical problem solving with others. So it's an apprenticeship process as well. And this is the chat room environment that we use in VMT. So there's a traditional chat over here, and then this is a shared whiteboard where they can draw pictures and figures, geometric figures and so on, that are shared immediately by everybody who's in the chat. And there are a number of features, special features that we've added to this. One is that you can point from a chat message to an area on the whiteboard, so you can talk about it. So Jason says, in this, for instance, and he points here, So we have this support for explicit referencing. And also message-to-message referencing. So when this person says yes and points to this message, you know that he's responding affirmatively to that message, whereas otherwise in chat, things can get confusing. We have social awareness features. So it says Jason is typing, so you know who's typing when, and you know who's in the room, a list of people in the room. And it also has awareness messages. Well, here's an awareness message here. The last whiteboard entry was by so-and-so. And also, you can scroll back in the history of the whiteboard, and you can also scroll back in the history of the chat, so you can see what took place. Oh, and these blocks pop up every time an action is done in the whiteboard. So if you're just focusing on the chat, you see when there's activity in the whiteboard. Here's an example of referencing. So this one is pointing to this area here, which is a complicated geometric figure, and I can't really read what he's saying. But he's talking about some area here that he's interested in, the mathematics of some area. Well, which area is it? And it's by pointing in the future, by coordinating what he says in the chat with what he's drawn here and using the referencing, that he makes clear what it is he's talking about. Otherwise, so in a face-to-face situation, I could just point and say, I'm interested in this area in here, by physically pointing, and everybody in the room sees it. But in an online situation, you can't do that, obviously. So this functionality is created to handle that kind of case and provide that kind of functionality. Now moving on to level 3, the community level, supporting communities. The problem in large communities like the mathematics education community is that the number of experts, the number of people who really understand and can communicate about mathematics and explain it and teach it well is very small compared to the number of students who want to learn it. And therefore, what we try to do is make that expertise available to them, but at the level of large learning communities. So the Math Forum has millions of students coming to it, and it has a much smaller number of experts. So by using the expertise of the mathematicians and math educators to design problems, to give feedback, and so on, at the level of the Math Forum community, then all the people who come there can take advantage of that. And they don't have to be on a one-to-one relationship with it. In addition, the learners contribute to the worldwide knowledge building. So we give them problems and collect their answers and make their answers available to other students. And therefore, just like the Web 2.0 idea of something like Wikipedia, where everybody who uses it is also able to contribute to it. The learners can contribute and therefore become apprentices at this kind of expertise. And also by sharing and critiquing, checking each other's work within the larger community, it overcomes problems that the small group might run into. So collaborative learning is often criticized. They say, what if you have a group of kids trying to solve some mathematics problem, what if they get the answer wrong? Then they've learned something that's not true. Well, if they post that and there's a problem with it, then the rest of the community can correct it. And it overcomes that problem of provincialism. Then the problem is, so we collect their ideas on a wiki pages. And so then the problem is they've got so much technology here. They have the chat, they have the shared whiteboard, they have the wiki, they have the lobby. How do we coordinate it all? And so within the, this is the chat environment again, we've added a number of tabs. So we have the workspace still, but then we have a tab which is another workspace that where the group can summarize what they've done in their session. Then we have a tab where the topic for their work is given, so they can always go back and look at that. And then we have a couple browsers that point to wiki pages for them. Actually, the topic is on a wiki page too. So this connects the workspace with the contents of the wikis, which I'll show you in a minute, and also with their help page. And then the summary, so the idea is that they can work as a group in the workspace and chat about it, develop their ideas, summarize them on this tab, and then post their summary to the wiki page. And that integrates then the discussion in the chat with the drawings on the whiteboard, summarizing it, which is an important cognitive process, and then posting it to the wiki, where they can, each group can look at all the other groups' results and respond to them. And so it wraps up the different technologies, integrates it, or begins at least to integrate it. These are three math problems that we've used in the BMT project extensively. And they're all kind of open-ended problems that allow a lot of creativity by the students. So this first one is, if you can only move along the grid, then moving from point A to point B, what's the shortest distance from point A to point B? Staying along the grid lines. For instance, this is a path. Is that one of the shortest paths? This is a path. This is a path. This one's not allowed. So these three, turns out, are all the same length. They're all actually the shortest distance from A to B in this case. How many other paths are there that are that same distance? So the question, how many other shortest paths are there, turns out to be quite a complicated problem that is open to a lot of exploration of a very mathematical type. And so any student's group that spends time struggling with this question really gets a pretty rich experience of mathematical exploration. Here's a pattern problem. The pattern starts here, builds up to here, goes on and on. And so here there's, on stage 3, there's 6 squares composed of 18 little sticks. So for stage N, how many blocks are there and how many sticks does it take to make it? What's a generalization of the rule there? That's it's less challenging than this problem, but still can involve quite a bit of good discussion by the students and a lot of different methods of approaching the problem. And so even once they've solved it, you can ask them, what are some other approaches to it? Or look at what another group did using a very different approach. And what do you think of that? And how's that compared to your approach? And then another set of problems was typical probability problems. We could do one with the pizzas that you just ate. Given different toppings, how many different kinds of pizzas could you make? That was one of these, I think. But the interesting thing is that we gave them half a dozen different problems that are kind of interrelated, kind of similar to each other. Not all the same, but there's, for any one here, there's probably a couple other problems that are similar and could be approached similarly. And in fact, we gave them, suggested 4 different approaches to solving typical probability problems, and then asked them as a community to solve these problems in using these different approaches, and to see that different approaches can solve a given problem, hopefully come out to the same answer if it has a well-defined answer. And so we asked each group to pick one problem and one method and work on that, and then post their result to this little cell of it, so that eventually they would fill out the whole matrix. The community would fill out the whole matrix by each group contributing one part of it, and then everybody could look at the other answers and see sort of probability problems as a universe of problems and a universe of approaches. So those are some of the problems that we've used in the VMT project. Here's a bigger view of the Wiki page that coordinated all of their results. So we've actually had quite a few findings published already, and you can the group as a group, and a number of people are in the audience from the VMT project, and together we've published about 80 publications already in 5 years, and they're all available at this site. In addition, there's 4 dissertations, PhD dissertations at the high school that are dealing with information behavior in online groups, that's Nan. Negotiating differences for shared meanings, that's Ramon. Sustaining group inquiry, Johan, who's at home working on this right now, I hope. And group construction of math artifacts is Murat. So these are all different aspects of what goes on in the chat rooms in the VMT project, looking at the data very carefully. In addition, somebody else at Drexel has already gotten a PhD on adoption issues in the VMT project. Somebody in Germany is working on basically what I've been talking about, how to integrate the technology. He's actually the developer of a lot of the technology that we use. There's people in Singapore trying out different things at the junior college level. There's people at Carnegie Mellon working on intelligent agents for the VMT project. And we also have people at Rutgers working in collaboration with teachers in Brazil to set up international collaborative groups using VMT to learn math together. Okay, so now I want to switch over from the VMT project to courses in HCI that I've been teaching along with Nan and Murat. So we're interested in a kind of design that's called design-based research, where you go through a number of stages. You prototype, a simple prototype, an initial version of your system. You try it out with real users, you analyze the result, then you refine your theory and your design, and you cycle through many times. So in the VMT project, we've cycled through uncountably many times, several versions a year. And we have students actually use it online, and we've analyzed it, and that's where our 80 papers have come from, basically, and our dissertations are the analysis of what goes on in the different versions of the VMT software. And then we, based on the analysis, we redesign it, we add the new features, some of which I mentioned. Now, in terms of HCI, this is a very different model from the traditional waterfall model, where you try to define the software, its requirements, and so on up front. You build it once, and then you throw it out for users to use. And there's very little thought in terms of the theory of HCI about redesigning it and so on. So instead of that, we start very simply. In fact, we started, our whole technology was just AOL's instant messenger. So we didn't build anything ourselves. We used something that the students already were more familiar with than we were. And we saw how they used it and analyzed what was missing from it and started adding on these other features to support not only the individual learning, but the small group and the community learning. Now, one of the problems is, and this is why traditional HCI didn't go this route very much, is because the prototype has to be good enough to really be used by users. And if you're going to not only use it in a laboratory under very controlled conditions, but actually have people online around the world using it, then you want it to be, or it has to be usable by them. And that puts a lot of pressure on it. And that's why we started with AOL, which was already a robust system. The usage also has to be situated, so we don't believe in laboratory studies very much. They're okay for specific research questions, but in general, for this stage, you really want to see how it's used in the real world by real students around the world and so on. And then the analysis has to focus on problems that occurred. And that's a time-consuming process. And we've developed an analysis method that we call chat interaction analysis, where we've learned how to analyze them in a way that we can understand what's going on in their situated usage and what needs to be prototyped in the next version. So in my class, then, the class centers uses collaborative learning as the basic mode of learning. It's the most central mode of learning in the course. And the collaborative learning focuses on the small groups of students in the class working on weekly design projects. And in each quarter that I've taught the course, I've given a different general problem or project for the students to work on. So one quarter, their project was to extend the VMT software which they used in the course. So they first got firsthand information about how it works and what problems it has, and they actually analyzed their own usage by looking at the chat logs that they had created in their first week of interaction. And they came up with different functionality that they wanted to use to extend the technology. Last quarter, we did I think it was last quarter, the Internet Public Library. So we looked at the Internet Public Library, which is being developed at the high school, and came up with, their project was to come up with new functionality, in particular to make it more Web 2.0-like, to emphasize social networking. Another quarter, we just focused on the idea of social networking, did some research to find out what that meant, and tried to develop social networking extensions, I guess, again, to the VMT software. So these are typical projects that we've been using as the design spaces for those courses. So again, looking at it from this perspective of the individual student learning, these problems give a very rich learning environment for the students. They're using all the technology that I showed you from VMT, and they're being given these problems that are really future-oriented. There is no existing solution for them. They're wicked problems, to use that terminology. They're very deep and rich problems. And they work on them in groups with synchronous chat discussion. They can look at their logs and reflect on it and analyze it. And then the different groups share their findings each week. So there's that sharing of what's going on. So if the course is given face-to-face, they give reports in the front of the room. Otherwise, they give reports on the Wiki. Now, I'll talk about it. The case this quarter where Frasier is also being used to capture their group reports. And then there's a lot of individual work, of course, that goes on. There's a big, thick textbook that they have to read. That's individual work. They have to write a journal about it. They have to do a big reflection paper on the whole course at the end. And one of the weekly milestone projects is an individual assignment. So there's a lot of individual work as well that's integrated with the small group and the class project. So going to the group level, I have a little experiment on what we might call blended learning this quarter, where I'm teaching 2 HCI courses, an undergraduate and a graduate. The undergraduate is in class, the graduate is online, and I integrate the two so that every project group has some students from each. So it has some students who meet in class with Nan and me, and they give their group reports in class. So the undergraduates represent the group that includes graduate students, and this is recorded automatically by the Frasier system, thanks to Colin. And then the online students can watch the Frasier, and they can see what went on in class, including how their group project was represented by the undergraduates. So the in-class time is used largely for these presentations and discussion and questions and so on, rather than by lectures. And instead of having lectures, I give them extra reading that conveys the content that we would have given in lecture. So here's the syllabus for one of the, I guess, last quarter. So we start week by week. We go through, and this is a textbook. This is a very comprehensive HCI textbook, and they read it cover to cover during the quarter. In addition, they read a number of essays. Some of them are by me and fill in, like I said, instead of lectures. So it explains the background of collaborative learning and of the CSCL field and other things that are relevant to their group projects. And it also has readings about the HCI techniques they're using, scenarios, heuristic evaluation, cognitive walkthrough, and so on. And then their project steps through week by week the different stages in the design-based research cycle that I went over before. So they start with a little design project, and then they do that online in their small groups, and that gives them some data that in future weeks they'll analyze their analysis and statement of problems. And then they'll establish some requirements and use cases, and then they'll do a conceptual design of some functionality that they individually came up with to meet the problems that they recognized in their analysis. And then they go through and do a couple evaluations. They prototype their conceptual design as a group, and then they evaluate it using a couple basic methods of HCI. And each week they revise their prototype. So it goes through a number of revisions based on the different evaluation. So there's a mix here of individual assignments and small group assignments, and it's all shared by the class community. Here's an example of the wiki. So basically, gives an overview of the course and the different aspects of the course, the different tasks that the students have to engage in are spelled out in the wiki. And then they post, so the online class posts their groups to the wiki. So here's a posting of a task analysis on a proposal that to add a collaborative calendar to the system for scheduling group meetings. And that's posted on the wiki where everyone in the class can see it and comment on it. And then here, this group, which was Group H, rated last week's reports by the other groups. So even the feedback that they get to their group work is peer feedback. It's not teacher-centered. So, and they do quite a nice job of critiquing the aesthetics of the presentation and analysis that went into it for each of the groups, and they rank which ones they think did the best job. So this way the groups get some feedback. How did our group do compared to the other groups in the viewpoint of the other groups? So that's all I wanted to present because we have three upcoming events here in this room where Nan, Johan, and Marat are going to present their findings about DMT. So I wanted to save some time for questions, answers, comments, critiques, peer feedback, and so on. Henry.
Yeah, I like it. I think it's a very interesting project, and it's giving really wonderful data for a lot of things. However, I'm a little bit concerned about the position of the students when they face all this, because we are, as teachers, we are learning to teach in this collaborative learning approach. But then the students also have, they should, have their problems in applying this or accepting this way of learning. So how you have, what is your experience in relation to these students? Like somebody has came and said like, listen, I don't want any student to comment on my work. It has to be the teacher.
They have to go through a transformation in their expectations about what education is all about, just like the world is going through. And it's not an easy transformation, and particularly people who are technically inclined, as many IST and Drexel students are, find it very hard to make that transition because technical training has always been extremely competitive and individualistic. And it's a very difficult transition. The ideal would be to go through an educational 4 or 5 year program where you get gradually introduced to it. But that's not an option at this point. And so it's very, on the other hand, when they graduate, and this is what I tell them the first week, is that when you graduate and you go out in industry and you're assigned to a team to work on a project, there's not going to be an instructor there where you can get your feedback from. You're going to get your feedback from the other people in the team. And you're going to have to work on the assignment that the team gets and work on it collaboratively. And a lot of people, especially the graduate students at Drexel who have been on co-op, they realize that this is the way. And so they've gotten a little used to the model of collaborative learning on co-op. Students who come back and take a second course from me, they're great because they already understand how the thing works. Otherwise, we go through a couple weeks of some chaos.
Yeah.
There's an old theory of cooperative learning that goes back to the 60s. Jim, do you remember what's it called? You go through stages: storming, norming. What is it?
Forming, storming, and norming.
Forming, storming, and norming.
And performing.
And performing. Okay. So you form the group, and what's the first thing they do? They create a storm. There's all this chaos, all this whining and complaining. But in general, after some time, then it normalizes, and then they can perform. And this is the cycle they go through every quarter. They complain, how can we do this? This isn't what I wanted, what I expected, and this is not what I'm used to, and this is not what I know how to get an A at. But then generally by the end, they see the advantage of it. And so basically I try to give them a rich learning environment, and I don't expect them to master every aspect. They're supposed to be multitaskers. Let them pick out the tasks that really interest them and let them excel at those. And let them do a minimal of some of the other things, and that's fine with me. And within the group, also, they get a tremendous support within their groups. So the group can balance things out too. If there's somebody who likes to do graphics like a collaborative calendar flowchart, then that becomes their thing that they focus on in the class, and other people focus on, standing in front of the room and giving the report, or reviewing the other groups and ranking them. And I try to encourage them to do all of that as collaboratively as possible, but they also always do some dividing up. And I don't expect every student to excel at every aspect.
No more questions?
So I can ask some questions.
Yes, you can.
Can I ask a series of questions? Would you say, so what if I said VMT is great for people who can't get together, but really sort of the small group collaboration that you're talking about solving math problems is really best done face to face, and that VMT is kind of a second best to that?
First of all, one argument for using online learning in face-to-face classrooms is that the face-to-face time is so limited. There's only so much you can do in however long the class period is. And so allowing people to work online in groups extends the time to however much they need. In our analysis of the chats, I don't see much evidence that a well-supported system, online system, can't be just as productive for math problem solving as a face-to-face. I think the harder, actually, if I may repose your question, the harder question is, isn't math problem solving in particular a very individual task? And certainly people who do math and do it well and extensively are very used to doing it as individuals. And you'll see even in the chats, people will sometimes say, wait a minute, I need to go off and think by myself for a while about this problem. And I think that's a hard question, but I think that people can get used to, they can change their way of doing it, and learn to solve math problems collaboratively. And I think that has many benefits. One benefit is that you get different perspectives on the same thing that one individual would not have thought of, approaches that other people think of. So somebody might make a proposal or suggestion of how to approach it, but not himself or herself know really how to carry that out mathematically. But the group can succeed in carrying out that suggestion. And so you get a pooling of skills and resources.
So, my understanding of mathematicians is that even when they're working individually, they're working collaboratively, right? It's just stretched out over a longer period of time. So you give a presentation on a problem, and then somebody else goes off and works on it for a while. So it's really a collaborative process, but it's just it takes a really long time and it involves a lot of individual work in that process.
Right.
And what you're saying is the student version of that can stay more compacted and more social, more interactive. Because I was thinking in a related sort of problem is I was thinking that the thing about your HCI course is that, and we may have talked about this before, in your HCI course, the subject matter is the same thing as the experiment you're doing. You know what I mean? You're teaching HCI, and so what they're experimenting in HCI is part of the subject. But I was thinking, well, would that work for a social theory course? Because in a social theory course, is there really substitute for sitting down and reading Max Weber in detail and then sitting around and talking with people about it? And really, does it matter whether you do that online or face-to-face?
I haven't thought about social theory courses.
I think about them all the time.
I'm sure you do.
Yeah.
I'd like to, but
I
it's taken all my time to think about HCI and math.
I have also done studies in which I have introduced a web-based tool online in a face-to-face classroom. I remember that at the beginning we thought that it was going to be like a problem, but later on we observed that the students were supposed to be reviewing papers, and we observed that instead of when they came to the classroom, the negotiation or the discussion was going beyond the topics that they have already touched or talked about on the web. So in a way, it was expanding the discussion. So it was not just the same discussion, or it was like again the same level. Instead, when they were face to face, the discussion was, according to the teacher, was to a higher level. So it might be the same case for your situation.
There's a lot of research on that would be relevant to your question about NCSCL using jigsawing and argumentation. So if you have four students in the group and you assign a different reading to each of the four, a different theory to each of the four, and then give them a problem that all four theories can address, and have them fight it out. That would be one.
Well, you have a case study.
Any other questions or comments? Well, thanks for all coming.